Hi everyone, I'm Dr. Jitin Jagannath, the Chief Scientist of Technology at ANDRO Computational Solutions. I'm also the founding director of our Marconi Rosenblatt AI/ML Innovation Lab. Today, I'm going to talk about DMARVEL, a technology that enables vision-based autonomy for unmanned aerial systems. This was developed as part of our NAVAIR SBIR program. As you can imagine, the use of UAS has increased significantly both for commercial and DoD applications. And in challenging environments where, for example, the communication might be intermittent, a certain degree of autonomy might be necessary to avoid collisions to complete mission more efficiently. So if you're in the market to improve your unmanned aerial system with really lightweight, vision-based autonomy, DMARVEL might be your answer. ANDRO Computational Solutions was established in 1994 with its headquarters in Rome, New York. We have significant experience in SBIR programs, phase 1s, phase 2s, and then maturing it into phase 3 efforts. As a result of which, ANDRO received the prestigious Tibbets Award in 2015. Within ANDRO's Marconi Rosenblatt AI/ML Innovation Lab has several areas of expertise. The focus of this talk is going to be at the autonomous UAV, which includes collision avoidance, human-machine teaming, and we have also developed technology for heterogeneous swarms. All right, let us first start by understanding Navy's challenge and interests. The need here is for a lightweight autonomy framework for unmanned aerial systems that can adapt to dynamic mission scenarios while enabling robust autonomous collision avoidance and interoperate with human warfighters when necessary. This can be seen by Navy's accelerated deployment of unmanned systems and can also be seen from other agencies like Defense Innovation Unit and Army's interest in UAS that can operate in GPS-denied environment. Now let's talk about specifications here. We want to provide unmanned aerial systems the capability to autonomously conduct flight from takeoff to landing. Provide the autonomy system to take in modified parameter from human in the loop when necessary and adapt to that in real time on flight by having the solution on the UAV itself without having to have a backhaul link to central cloud. Now, during this autonomous flight, it might encounter several obstacles. Can it in real time avoid these obstacles with really minimal number of sensors with a lightweight onboard system efficiently to provide the end user safety and maximum efficient operation for the mission? All right, so we have seen what's the need for the technology. Now let's talk about novelty and impact of DMARVEL. Towards the right-hand side, you'll see a diagram that captures some of the key features of DMARVEL. But let's go through some of the core bullets. So DMARVEL offers a novel modular approach to autonomy that actually captures best of both worlds, traditional autonomy-based approaches and machine learning-based approaches. Now, the framework was developed to provide robust autonomy using machine vision and perception, avoiding the need for costly ranging sensors and hover time. Now, in addition to avoiding need for ranging sensors, the solution is very efficient and low swap. In other words, it can go on small UAS itself, and it does not require multiple sensors, and it uses, for example, just a monocular camera. This doesn't mean we cannot additionally use sensors that are already available, but the key factor is it's now applicable to a wide range of hardware platform that might have just a monocular camera on board. In many cases, people use stereo cameras and ranging sensors to provide autonomy and collision avoidance. DMARVEL does not need that, hence saving energy, time, cost, and being able to be applicable for a wider range of UAS. Finally, the goal of DMARVEL is to operate in a GPS-denied environment through sensor fusion and machine vision. Now let's dive deeper into the problem statement. And if any of these problems sound similar to some of your mission scenarios or your challenges in a day-to-day activity, DMARVEL might be a solution for you. So the autonomy of UAS is itself a complex issue. It has to take into account robustness, collision avoidance, navigation, and in addition, it has to operate within the human team, which is not an easy task. The solution itself that uses traditional ranging sensors might require long hover time. The traditional autonomy solutions are inflexible to changing mission scenarios. So those might be key challenges that today's autonomy systems face. There are solutions that use end-to-end learning, but in many cases they fail in practice because it requires immense amount of data. So that's where using the best pieces from both worlds, traditional and machine learning based approaches, becomes important. And last but not the least, the key problem with UAS is the limited computational resources, whether it's power, whether it's computing resources, it becomes challenging. So you want to have the solution fast enough to be put on an embedded device and operate adeptly. So that's where DMARVEL shines. Now let's spend a couple of minutes on the solution DMARVEL. Let's start with DMARVEL's information flow. So on the right-hand side, you see block diagrams, which has the key components that come together to form DMARVEL, the onboard vision-based autonomy system for UAS. So it all starts with the monocular camera. So machine vision is used to perceive the environment on board and tries to reproduce this or produce a depth map and object detection. Next, the semantic point clouds takes the depth map object detection and then maps it into a 3D semantic occupancy grid. From there, an RL engine or a planning algorithm or both together decides what action to take, which is defined by mission or maybe defined by flight path it had in the past. All of this together provides an autonomous engine that enables any UAV to become that resupply or exploration entity during the times of GPS denied operation or broken data link. This altogether provides the operators or the warfighters much more efficient and safer way to resupply, to provide exploration, and to ensure that the mission becomes successful. Now, next, let's look at the key examples and key features that we have shown in the past demonstration. I want to also point out, feel free to reach out to me if you want to see videos of this. We have significantly increased our number of videos and demonstrations we have done from this point, but this gives you an example of how the system works. Now, on the right side, top image, you can see three windows. One is RGB. The second one is actually the depth estimation map. And the third one is the planning overview. In the images below where you have RGB and depth estimation map, it just gives you an example of how you can take a monocular image, then using deep learning, provide depth estimation. And from those depth estimates, you can see how deeper objects or objects far away are correctly classified as far away versus, for example, those three trees you can see there. You can see how as the trees move away and away, they are lighter and lighter, which is a proper estimation of its depth. We can also see there is not too much obfuscation between the leaves and other things. So all these components work well together to form the autonomy piece. But like I mentioned, please reach out to me if you want to see some of the demonstration videos that I can provide of the technology working on board on an embedded solution on the UAS, and we can discuss more regarding its operations. So thus far, we have discussed the need for autonomy and how DMARVEL provides that autonomy, including some of the impact and novelty factors of it. But one of our key requirements or goals is to transition the technology from the point we have developed it into the fleets so that the warfighters can benefit from it, keeping them ahead in the theater. To do that, we are looking to sign partnerships with larger DoD UAS manufacturers who might be looking for these capabilities. We are also in the process of identifying program of records and key decision makers who might help us demonstrate these capabilities to build a roadmap to schedule demonstrations and to ensure how much resources we might need for that. Similarly, from the commercial side or from the larger DoD partnership sides, we have worked with Lockheed Martin, one of the prime DoD customers, to see if there are opportunities to collaborate to put the solution in some of their drones. We are similarly pursuing other primes who might be interested. And if any of you see some of these solutions as a real problem for you in the near term or long term and want to discuss this further with me, I would always be welcome. And we can see how we can collaborate on enabling or enhancing the UAVs that you might already have in the house. Because the key aspect of our solution is the lightweight nature of it and the requirement of minimal sensors, which means even the simplest UAS can be provided with the autonomy capability of DMARVEL. So looking forward to those discussions. Now let's take a closer look at the market. So as a product, we see DMARVEL or DMARVEL subcomponents being licensed to either as a standalone format, which means it will include hardware and software, everything in conjunction as a payload that goes on the UAS, or just the software that can be licensed specifically for a US platform that might already have hardware that we need to operate. Now, what applications can we see DMARVEL supporting? You can think about tactical ISR, resupply missions, explorations, and DMARVEL's robust collision avoidance and semantic perception allows you to navigate fast to the resupply points or other points as required. Additionally, the novel natural user interface allows RF silent visual wave off when required in challenging environments where the mission scenarios are changing. From a commercial perspective, you can think about infrastructure, investment monitoring, asset monitoring. In terms of insurance, you can think about risk monitoring, risk assessment, and claims management from fraud protection. Other than that, you can think about transportation, media, entertainment, and many other applications where UAS or drones have been used today, but you need autonomy to increase efficiency and maximize the use of the flight time, which are usually limited. Now, thinking about all these solutions, anybody who might need DMARVEL to enable autonomy and they have a system that's small enough and needs to be efficient, that's where DMARVEL should shine. So finally, to wrap up things, we have demonstrated some of these capabilities on commercial UAS. We want to continue to do that, work with partners who might need the technology to try and put the solution on their UAS and provide them demonstration for them and their prospective customers. We want to look at SBIR Phase 2.5 and other program of record opportunities where we can mature the solution and provide that transition path. We want to target UAS manufacturers who might be looking for these autonomy solutions, especially when the requirements or the capabilities needs to be applied on UAS that have minimum number of sensors because of the weight that it needs to carry, because of the limited flight time, and so on. So where DMARVEL stands out or makes it easier for these transition and maturation plans is it's a modular design. It's built on open source software architectures that use things like Mavlink and PX4, which is pretty common and easy to integrate with something that's already there or a flight system that might be already there. Similarly, like I mentioned before, it uses minimal sensors. At this time, we are using for vision-based autonomy, we're using a monocular camera, which means you don't even need to have stereo cameras or other multiple cameras to make this happen. So if you have a monocular camera, this could be put on the UAS, and if you don't have, we will have a subsystem that includes these low light, low weight, low swap solutions that can go on an already running UAS. And then finally, these properties allow for this to be an entity on multiple kinds of platforms. So we're not tied into specific requirements in terms of sensors, capabilities. We want to make sure that the solutions can be implemented and demonstrated on as many transition UASs as possible. So that's our main goal here. I want to thank everyone for listening. And if you have a solution or if you have a mission plan where autonomy is a part of the solution or is the core of the solution, if you have limitation in terms of computational resources or the sensors that you can use and have UAVs that you wish had the autonomy, vision-based autonomy solution, feel free to reach out to me. We can discuss about the technical, more detailed aspects of the technical approach. We can also see some of the demonstrations and how we have implemented some of the solution on as an embedded software solution for UAS. So thanks once again. As I mentioned, feel free to reach out to me if you need more information. Thank you.